Alright, hello. My problem was asking, explain Lenz's law to us and show us a few examples of its use. So to do this, I'll start off by writing Lenz's law, which is an induced current is in a direction so that the induced B field it produces opposes the change in B flux. So when it says the induced current is in a direction so that the induced B field it produces opposes the change in B flux, that means when we have a B field and the B field is increasing, then the induced B field right here opposes the change in B flux. So the change, so if it's a positive change, it'll oppose that and go negative, and if it's a negative change, like it's decreasing, then it will oppose that and be positive. So and if there is no change, then the B induced will be 0. So a few examples of this use, there's like the first general one. So like you can have a like a solenoid with that goes in this direction, and with the resistor there, and you can say like you're moving a magnet out of this solenoid like this, the north pole here and the south pole here. So if you are increasing the movement of this magnet out of there, you can find out which direction the induced current will be in this wire. So you start this by, you know that the magnetic field in this magnet in the solenoid looks like this, but it is going this way, so the B field will be decreasing in here, and because the B field is decreasing in here, you know the B induced will go this way. So this is the B induced, and when you have the B induced going this way, you can use the right hand rule to figure out which way the current is going, and you'll get that the current is going this way, moving this way around the coils and back through. Another example is if you have a solenoid like this. So I'll just quickly draw this. So this is a cut of a solenoid where it's like this, where this is the backside, and right here they're all going in, and right here all the wires are coming out at you. Excuse me, I have a cold. And then you have a wire that goes around like this, and so in here, in the actual solenoid, you know that the current is going this way. So using Lenz's law, we could figure out the induced current in this wire that goes around this solenoid due to the change in the B field from the solenoid. So we'll start this off. We also know that the B field in the solenoid is increasing. So we know that because of right-hand rule, we know that the B field is going this way in here and is increasing. And when that's increasing, we can look at it from the other view, like this. So we know that the B field is increasing at us, and therefore when it's increasing at us, we'll know that the induced current in the loop around the solenoid will be going clockwise this direction. This is the I induced. Alright, I think that is proper two examples of how Lenz's law works and what it does. It basically just shows how the change in a B field will induce current in a wire or a loop. Alright, thank you.